We've seen earlier in our course several techniques for solving quadratic equations. These are equations that involve the second power of a variable, but no higher. We've already seen how we can use factoring techniques to accomplish that goal. However, not every quadratic equation will yield to factoring techniques, because not every quadratic expression may be factored over the rational numbers. In this video, we'll take a look at a technique that we can use for any quadratic equation whatsoever, whether it may be factored or whether it may not be factored. The formula that we'll learn in this video can give us the solutions of that equation if they exist. To solve the equation x squared is equal to 5x plus 1, we'll first recognize that because this looks like a quadratic equation, our top priority should be to move all of the terms in this equation onto one side so that the other side becomes 0. That's always the first step, whether we're using a factoring method or whether we're using the method in this video to solve a quadratic equation. Always get one side to be 0 if it's not set up that way already. So in our example, we'll subtract 5x and we'll subtract 1 from both sides of this equation, so that the left-hand side is x squared minus 5x minus 1, but the right-hand side, most importantly, is 0. Now that the right-hand side is equal to 0, we would traditionally look at the quadratic expression on the left-hand side and attempt to factor it. Factoring this expression as a product of two binomials would lead us to ask the question, what two whole numbers multiply together to give us -1, and also add together to give us -5? Well, unfortunately, as hard as we try, we're not going to find a pair of whole numbers which accomplish that task. Because the only pair of whole numbers which multiply together to give me -1 are +1 and -1. And that pair of numbers do not add together to give me -5. So the factoring methods that we know will not work to factor the expression on the left-hand side of this equation. So clearly, we need something else in order to solve this particular quadratic equation. That something else is called the quadratic formula. To get ready to use the quadratic formula, the first thing that we'll need to do is identify and name the three coefficients in this quadratic equation. We call them a, b, and c, and they have the meaning of being the coefficients, respectively, of the second power of x, the first power of x, and the constant, in other words, the 0th power of x, if you like. So in our equation, a is the coefficient of the x squared term. We didn't write a number next to x squared here, so there is a hidden 1 as the coefficient of x squared, making the value of a, our quadratic coefficient, equal to 1. b is the coefficient of the x to the first power term. Here that coefficient is -5. Take care to keep any negative signs with their respective coefficients during this process. Likewise, c, which you think can stand for constant, for example, is the coefficient of the term which does not have an x, and so in our example is -1. Bear in mind that depending on how you write the expression on the left-hand side, you can change the order in which the terms appear. We could put the -5x before the x squared, for example. But a, b, and c do not depend on the order in which the terms appear, but they depend on which coefficients are attached to which power of x. So you'll always find the a coefficient attached to the x squared, the b coefficient attached to the x to the first power, and the c coefficient is the constant term which has no x. Once we've identified a, b, and c, the quadratic formula is a recipe that tells us what to do with those three numbers to produce the solutions of this quadratic equation. The formula looks like this. X is equal to -b plus and minus the square root of b squared minus 4ac, all divided by 2a. This is a nasty-looking formula, but it is worth memorizing because it is so versatile and powerful. The cost of using the quadratic formula, which can solve literally any quadratic equation for you, is the use and memory of this somewhat challenging looking formula. But if you have this formula at your disposal, using it requires nothing more than substituting for a, b, and c the numbers which we've just identified as the a, b, and c coefficients of our quadratic equation. So, in place of b, we'll put the number -5. So in the beginning of the formula, which begins with minus b, we will have minus the quantity -5. Then underneath the big square root sign, we have b squared minus 4ac. So in place of the b, we'll again very carefully, using parentheses, substitute the number -5. In place of the a, we'll substitute the number 1, again parentheses. In place of the c, parentheses, -1. And in the denominator, where we see the coefficient a, we'll substitute parentheses 1. So we've substituted all of our coefficients into the quadratic formula. And the rest is nothing more than arithmetic manipulation. We just have to figure out what numbers are being represented by this formula. That requires us to evaluate this formula using, as always when we evaluate, the order of operations. Along the way, there are many opportunities to make sign errors, to lose a negative sign, to have one too many negative signs, and this is typically where students err when they use the quadratic formula. So let's try to be really, really careful about signs along the way. First of all, the very first term, minus the quantity -5. When we simplify, that becomes minus a minus, or plus, positive 5. Then we have the plus and minus symbol, and the square root of the quantity -5 squared. Again, this is why these parentheses are so important, because with the parentheses there, -5, the quantity squared, becomes positive 25. So be careful of that sign. Then, according to the order of operations, we need to multiply 4 times 1 times -1 before we're able to do the subtraction underneath the radical. Well, 4 times 1 times -1 gives me -4. So underneath the radical, we have minus the quantity -4. Again, very careful about those signs. And lastly, in the denominator, 2 times 1 is equal to 2. We have one more opportunity to commit a sign error when we carry out the subtraction 25 minus -4. Well, to subtract a number is the same as to add its additive inverse. So 25 minus -4 is the same as 25 plus +4, or 29. So underneath the radical, we have the number 29. And we've now simplified this expression as much as we can to get 5 plus and minus the square root of 29, all divided by 2. Well, what does this mean? The last interpretation that we need to bring to the table is what to do with this symbol, the plus and minus sign. That symbol is intended to convey that there are two possibilities for this value of x, which in general we expect from a quadratic equation. One possibility occurs from taking that sign to be a plus, and the other from it being a minus. So the last thing that we'll do is break this expression into two separate possibilities. One of them where the plus and minus sign is replaced by a plus sign, giving us 5 plus the square root of 29 over 2. And the other in which the plus and minus sign is replaced by a minus, giving us 5 minus the square root of 29 all over 2. That's the source of our two different solutions for x in this equation. And in our example, there's no more simplifying that we can do to make this expression look any simpler. So to use the quadratic formula is something that you may not know that you want to use when you first start solving, but when you subtract all the terms in a quadratic equation onto one side and get a 0 on the other, you might realize you have an expression that does not look like it factors. Or maybe it does factor and you're just not feeling like you want to factor it. It's the great thing about the quadratic formula is whether or not you can factor doesn't matter. The quadratic formula will always give you both solutions. To use it requires identifying a, b, and c, respectively the coefficients of x squared, x, and the constant term. Those coefficients, by the way, are always just numbers. You won't bring along any of the x's into the evaluation of this formula. Just in this example, 1, -5, and -1. and then plug those coefficients into the quadratic formula, which is the most complicated thing that you will have to commit to memory for an algebra course and perhaps any course leading up through calculus. But if you commit this to memory, using it will automatically give you the solutions of this equation. But be very careful along the way, because everywhere in this numerator is an opportunity to commit a sign error. There's an opportunity here where you take minus b, the opposite of the b coefficient. There's an opportunity here where you square b, which, by the way, will always be a non-negative evaluation, so positive 25 in this example. There's an opportunity here when you multiply 4 times a times c to commit a sign error. And then finally, there's an opportunity here when you subtract b squared minus 4ac to commit another sign error. But if you can safely navigate your way through all of those potential sign traps, then what you get at the end is an expression which contains two different answers in it. One expression which results from taking the plus sign to replace the plus and minus, and the other which results from taking the minus sign in the plus and minus.